Okay. Hello. I will, start my session today. Before I, really say my topic, I would like to make a strong, statement about SD-WAN. So SD-WAN solution is one of the compelling use case of SDN, and it helps to enable efficient orchestration and management of WAN, along with dynamic insertion of new services, and bring down the overall WAN costs. So with this, let me go to my, topic. So my topic is importance of SD-WAN and how we can use ODL as an SD-WAN controller. So I will basically walk through a case study in which we have used stock ODL and implemented some scenarios using a low-cost device. So about me, I work with Happiest Minds, and a little bit introduction about Happiest Minds because I guess we are pretty new into this area, but we are there for past 5 years, and we are around 2,000 employees and really growing fast. And our contributions are into software and hardware services, and we basically are so working towards solutions which will so basically transform the future. And around this, basically NFV SDN is the area where I work, and I have a small team, and we are 100% committed to developing softwares using open source. And so there are some basically interns also, and they really helped to develop this the case study that I'm going to show. So the next few slides are about my organization. So I'll just tries to basically go through, and you can basically see the EPT, and maybe if you have any interest, you can talk to us. So these are the areas on which we are working. And okay, so now let's talk about the agenda. So I would start with by as drawing few as data points from the market survey, so that we have for SD-WAN, and then I'll explain a brief about traditional WAN and the SD-WAN architecture, because just to give you a brief recap of the basic concepts before I really go and explain our as a case study using ODL, and then little bit on what we feel is the next in SD-WAN, because I think all of the current implementation in SD-WAN are basically centric towards the enterprise solution. But I guess the trend is changing. So and I have a demo which is basically a video recording of the about the rising demand of SD-WAN. So whether you talk about the branch connectivity or site-to-site connectivity, or even basically a home gateway, the statistics say that there is a big amount of demand. Also, with respect to the deployments, we are seeing that all the vendors which were so basically a part of the survey, they either have a solution which they are basically deploying, or they would be completely basically deploying it in the next 2 years. So now when we talk about SD-WAN, it makes sense to really basically as walk through what are the challenges in the traditional WAN. So these are all basically known facts, the challenges. So let us see what are the the deployment architecture of the traditional WAN. So a brief recap. I think all of you might be aware of how the the traditional WAN looks like. So basically you have an MPLS link, and then you have basically a backup link. The MPLS link is a primary one. The backup can be a secondary one if the primary fails, or in some cases there are some static configuration, like maybe all your traffic towards the data center you pass through MPLS, and some of your non-critical traffic you pass through the internet. So very so well-known architecture. Another one is where you really have only one connectivity. So even your access to the internet is backhauled through the data center. So this is one. So now, what are the inherent problems with this architecture? So the problems are, definitely with the with respect to the configuration. So which is very well known. So there are, inherent problems. Additional problems are there because of, the increase in the volume of, the WAN traffic, over the years. The kind of applications have really, increased. Like you have now, basically Office 365 application. You have, basically connecting to, the virtual desktop infrastructures. You have a lot of, video streaming happening. So really, the WAN has a lot of, pressure on the bandwidth. So apart from, inherent problems of, hop by hop configuration and basically manual provisioning in terms of, basically a backup and, stuff like that, you also have a problem of inefficient bandwidth utilization. So in this kind of an architecture, even if you want to do a simple Google search, all your traffic would, ideally go through the data center to the internet. So MPLS links are basically very expensive, right? So if you really make a comparison, MPLS link, per month, per Mbps, could be around, 10 to 20 times expensive than a broadband link. So in this kind of architecture, you really have no scope to reduce. You have no scope to really say, okay, these applications are non-critical. It makes no sense to, pass through the data center. So let me, pass it through some alternate link. So these are some of the, inherent problems, which are, solved by, SD-WAN. Now SD-WAN is still in its, deployment. It's very, very, new. The entire solution has not, matured enough. But yes, there are, capabilities available, which we all know with, any kind of SDN, solution, which can, solve these problems. So the problems of complex provisioning and management, or lack of traffic and bandwidth management, all of these, there are solutions available with, SD-WAN. So let us quickly see the architectural concepts. So very, very, simple, and it is, all known by people. So, what you have, here is an overlay network with a, with a SDN controller having access to, all the edges, and the controller can really do all kinds of orchestration, management, and basically steering of traffic. It can do basically bandwidth management. All such things can be done from a centralized, as a pane of glass. So, so this is, and this kind of, deployment can be both be, CP centric, or it could be also at the cloud. So why I say like that, an enterprise can have a solution at its edge. It may not have a lot of, branch offices, so it can really basically apply the orchestration and the management, basically available using the controller, and he can basically steer the traffic. He can do a lot of, bandwidth management, insert a lot of new services, or it could be at a cloud also. So, so typically, such solutions are, available today, but so mostly they are basically enterprise solutions, and so there's a scope to add basically newer solutions from the service provider side also. So that I will talk about it later. So let us see some of the key use cases of, SD-WAN. So, first is, the centralized, management. So it's very, very easy to insert basically new services. So whether it can be a firewall, IPS, antivirus, or, basically a DPI, you can really, really say that, per application, you can basically steer the traffic, based on the priority, based on the complexity, and you can reduce the amount of bandwidth that you are basically consuming, over the MPLS. Second is, if the SD-WAN solution is from a service provider side, like if it is offered as a managed services from any service provider, then there is ease of, the configuration of VRFs, LSPs, and LER in an MPLS domain. So that would mean you have basically predictable uptime of any new services. But typically now, if you want to deploy MPLS service, it almost takes a week or so. But with SD-WAN into picture, these configurations will be basically be very simple, and you can have uptime in the order of days if you are using SD-WAN. Traffic and as a bandwidth management. So as the architecture showed, you can basically dynamically steer the traffic, along the available WAN links. You can also, determine and improve the application performance. So, you can basically gather statistics on, how your application is basically performing, and based on the statistics available, you can take a decision to, so maybe shift some of the applications from, the broadband link to the MPLS link. Or you can also, so do the reverse. If you see that, okay, some of your applications are using MPLS, link, and they are not, so basically critical, you can, basically, so move them to the broadband link. One very important use case is, the using of some anomaly detection algorithm. So the controller gives a lot of, basically statistics, and those statistics, can be fed to an anomaly detector. So in our, case study, we have a, solution in Happiest Minds, which it is basically an anomaly detector, and it can basically consume actual, data sets and, give you outliers. And based on these outliers, you can give a feedback to the controller to basically update the policies that, were already, earlier, configured. One of the other important use cases is internet as a WAN. Now, SD-WAN, gives a lot of, opportunity to service providers who actually do not have an MPLS base. So in this, use case, if you have, multiple internet links, let's say you have a broadband, or you have a fiber, you have, so basically a wireless, or, so basically DSL, you can basically mix and match among these links, and you can have a WAN using internet, which can be, so business grade. So this is very, very useful for operators who do not have an MPLS base. So now let us look at, the case study. So this is basically a solution that we, so developed for one of our, customers, and the request from the customer was, so two requests. First request was they wanted it to be very, very, cheap and, portable, so that, they could really take it to some of the conferences and basically show it. Second, the app that we have, developed on top of, the controller should be used on any underlying, hardware, and it can be, so basically be demoed. So we have not made any changes in the ODL. Personally speaking, I am, still in a phase in which I am, trying to explore ODL. So I come from, basically networking background, and I'm really excited to, do something with ODL, but I'm quite new to it, as compared to my team members. So, so let us look at the solution setup. Very simple solution using Raspberry Pi devices. And let me just say the components here. So we have used a Raspberry Pi device, and we installed the OVS here. And the ports in the Raspberry Pi devices, I have, so mimicked it. So for example, one of the ports, which is the internal port, so this acts as the outgoing traffic from intranet, let's say, or, the outgoing traffic, from the WAN. And these are the external interfaces available to me. So I, I name it one as, a DIA. So it could be a, fiber, or, basically a broadband. There's a Wi-Fi interface also, but in my, the case study, I have not used it, but, you can, install open for rules to do that. And one of the interfaces, I say that this is an MPLS. And over OpenDaylight, as a Beryllium, I have installed this, the SD-WAN WAP, which will, push the simple, JSON rules. And these rules are simple enough to say that, okay, if there's an, a traffic coming with this particular, port number, try to direct this traffic to an external port 1 or external port 3. So let us see some of, the use cases of this solution, and some examples which can be built around those use cases. So as I was, talking about, the problems with the traditional WAN, and how, SD-WAN as a solution can bring a lot of improvement over it. So this use case is basically, traffic redirection and bandwidth management. So I can, okay, so, before that, how, some other components of this particular, so setup is an iPerf client. So this, I'm running iPerf clients to simulate various kinds of traffic. So I have, simulating, around 5 kinds of traffic with, various, port numbers, and then applying some flows over here, and then, I have an iPerf server over here, which basically, consume the traffic. So this is a use case. It can be used to show, how we can have, substantial, cost savings if we can basically direct some of the traffic from MPLS to the DIA. It, so does not stop here. You can actually add flows to stop any kind of traffic. You can allow any traffic. You can do so many other things with this, the traffic redirection and bandwidth management. In our case study, we also basically monitor the bandwidth. So if any application is consuming basically more bandwidth, you can insert flows. So currently, all the flows are basically static flows, but our goal is to basically harden this over a white box switch so that dynamically you can do all these operations. The next case is of intelligent as a traffic control. So here we insert flows to mirror the traffic. So we would say that, okay, we want to basically monitor any kind of external traffic, so that is coming into our network, and we basically mirror the traffic to a monitoring device, which could be as simple as basically a Wireshark, or it could be a IDS or an IPS system, and then we can give some feedback to the SD-WAN web. So now it is all basically static. So you see in the Wireshark, and if you're really interested to stop that traffic, or maybe you do not want to as a mirror it, you can do all such kind of configuration using this app. The another case is of anomaly detection. Here we are using our tool. So we have a tool, as I said. So this tool can act upon as a data sets, and it can give you outliers. So a typical example is for example, if your source IP destination IP is changing for a pair of endpoints, or you are observing that at a particular time of the day there is a drop in the traffic by observing the statistics, then this anomaly detection can give a feedback to the SD-WAN app. So and then using that feedback, you can appropriately update the flow rules in the as Raspberry Pi devices. So this is basically a work in progress. So we currently are in a state where we are are able to send the configuration to the AD tool, and the feedback one we are actually now working upon. The next use case is basically service insertion. So here, what we do is that we are, we can add, so basically any new kind of service. For example, we can add a firewall. So we can add appropriate rules from the SD-WAN, WAP, so that we can add a firewall, so let's say for the traffic that is incoming traffic. So we may not be interested to add a firewall on the MPLS link, but we can. So we think that there is a need that to add a firewall on the the external traffic, and we could also allow some the application of certain rules such that if the firewall is somehow down, it can basically so disrupt the the incoming traffic. So these kinds of use cases can be used in a commercial so deployment if the solution is basically hardened. So now, so with this, I come to an end to the contents of the PPT. So with SD-WAN, what's the road ahead? So if you see the kind of solutions today available in the market, they are more enterprise centric. So it means that an enterprise will have complete control over the traffic that is going out, or it is coming in, and using its various infrastructure available, whether it is an antivirus or IDS, or so maybe a deep packet inspection, it can basically control and manage that traffic. Or it could be over the cloud, and it could enable the enterprise to basically control the traffic flowing along as among its branch offices, or from the branch offices to the cloud. But this is just one part of the story, because SD-WAN has two components: one at the enterprise side, other is at the service provider side. So I feel there's a lot of demand from certain enterprises to have a full-fledged managed services, which is basically SD-WAN. And the challenge then would be to basically harden that solution so that it is basically carrier grade. And also certain very important features of SD-WAN, like so zero-touch provisioning is still not available. So these are some of the challenges which we will see with SD-WAN deployments in the future. So I feel enterprise is okay. So it's we have basically solutions available. The next big challenge is how does enterprise adopt the current solution available? So enterprises will have their own infrastructure, which are so basically a firewall or an antivirus, IDS, IPS. So the current enterprise SD-WAN solution has to coexist with this particular solution, and also they have to scale up, because a lot of investments have gone through to put this particular service in place. And with the WAN budgets really coming down, I think the current solution should really basically scale to so coexist with the existing security stack, and also so basically scale up. So now I will move to our demo. So let me just. So the demo, topology is slightly different from the solution setup that I had shown. So just yeah. So so this is the app, and the app so gives you an option to choose a a particular link option for the services. So services could be an SAP, or maybe IMAP, ICMP, or YouTube, Facebook. So we have basically mapped these services to various ports, and open flow rules are inserted by the controller to the switch, and the switch acts according to these rules. And yeah, so let me talk about the topology a bit. So so there's a change in the topology. What we are doing it here is that the enterprise client, which is the outgoing traffic, is one PC, and we are also running the iPerf so client there, as well as the ODL controller. So we wanted to have a setup which is so very so small in terms of the number of equipments that we can use. So both the ODL controller and the iPerf clients are running on the enterprise client. And the endpoints that you see there, MPLS and DIA, they are again one single PC, and we use basically namespace to so segregate the iPerf servers that are running corresponding to the clients that are running in the enterprise client PC. So these are some of the statistics that we pull from the ODL. So for all the ports, we have the statistics, and an addition for the loopback. currently, you do not have any rules. I don't know why it's just going back. So these are some of the so default rules there. So since we are using the one single port for both the controller as well as the iPerf, so we added additional rules there so that we can allow SSH from the enterprise client and we can start the iPerf. So so that's one. And we wanted to avoid additional traffic going to the controller, so we added so one more rule so that all the traffic with this particular priority should not flow to the controller. So we had some problems to really synchronize the the traffic flow. So so what we are doing is that we are actually installing the flows and then trying to do a ping and then check. So you could see that you are now seeing some so DIA traffic once you activate the link option as as a DIA. So now we'll select MPLS and so we'll start the iPerf server. So endpoint, 3 is the mirror port. So we now, we don't have any traffic there, so you don't see, any output, so from the TCP dump. So we try to so measure the bandwidth of the incoming traffic here. So here you could see the MPLS endpoint receiving the traffic. And the bandwidth of the port here. So now we'll show you the port mirroring. So endpoint 3 is basically simulated as a mirror port. So there's a little drop in the bandwidth shown here. Most of the other the part of the videos are almost similar. So we'll try to see whether both MPLS and so basically DIA traffic can be injected from the switch towards the endpoint. So this is basically the DIA port on which we are mirroring the traffic. So we'll start, as both the iPerf client for DI and MPLS, and the endpoints now show you the both the MPLS and the DI traffic. So here we have a little drop in the bandwidth because it's a single port, so basically 100 M. So the iPerf is so basically splitting the traffic. So so if you add up so both, it's almost like 85% is what the bandwidth that we are using now. I think that's all about the demo. We have some additional screens which show the statistics very similar to the one that I had shown in the beginning. Yeah. So so here you could see the flows for both the incoming and the outgoing traffic. So that's all about the demo. So now if you have any questions, you can ask. Yeah, please.
So you can configure the bandwidth management, right? You can say like how much traffic you want to go through the MPLS or what type of traffic you want to go through MPLS. Is there a way to template that, create a template out of that, and then use that to apply at different customer sites or things?
I think yes, I think it's possible.
Okay.
So here, we have, the application is not having any state, or we are not, doing any, bulk, configuration here. But yes, it's, it is possible. Yeah.
So typically in a SD-WAN deployment, like probably you would have considered, like we are just showing the one end of the deployment.
Yeah.
So there should be like on the data center side or the other branch or the remote office, we should have a two controller which would be syncing their data.
Yeah.
So that is done in this one?
Yeah, no, so this is, basically at the enterprise side, and, as I said, most of the WAN deployments are, heavily engineered towards enterprise. So this will not, or, this has no capability to do any configurations of, the MPLS edges or maybe the LSPs or the LER, so it has no capability there. But actually, so when I talk about the SD-WAN, so challenges. This is the main challenge that the SD-WAN as a service, so basically end-to-end, from a service provider, where a service provider is able to, basically configure not only the edges but also the, the MPLS nodes. So, I think, from an, the NFV perspective, I think, we are, slowly, so moving towards it, wherein, the operator, ideally would have all the, virtual functions, and, so like a firewall, like, an IPS, IDS, along with, basically WAN optimization solutions, or basically SD-WAN, and, typically, then you could really, from the NFV, you can, talk to, the virtual service gateway, which ideally talks to the, the provider edge, and you can do the configuration at the edge, as well as you can talk to the CP, and then you can also configure there, so that the entire WAN, as a service can be provided. But here it's not possible now.
Thank you.
Okay. Thank you for joining.